Okay, everybody. Sorry I'm not there today, but this isn't that hard of a lesson. I've got about, let's see, 9 problems to do with you. We are going to do limits using tables. Last class we did limits graphing visually, so now we're going to do it with tables. The only thing that can get complicated with the calculator is that the calculator will not show you where the holes are, so that's why the tables are a nice way to actually see that there's an error there or a hole in the graph. So let's start by what we need to do in terms of tables. On everything on homework tonight, I want a table. On every single problem, I want a table. So what you would do is you just type the equation into your calculator. So x squared minus 1. You are going to go to your table set, which you hit second window, and it comes up as table setup. This is where you want to start. Okay, so your table starts right there at 1. But your change in table, your change or triangle delta table, you want it to go by 0.01. Sometimes you want it to go by 0.001. It depends on the graph, but 0.01 is fine for me. Then you go to second graph and you go up 2 spots. Oh, look at that. I didn't change my table. Do that again, 0.01. Second graph, up 2 spots, and you are going to copy the 2 spots above where you're starting and the 2 spots below, and you can even include the 1 if you want to. So let me copy this. So 1 would go here, that's where you start. 2 spots above would be 0.99, 0.98, and then 2 spots below would be 1.01, 1.02. And you have, let's see, negative 0.0396, negative 0.0199. What does that look like it's headed toward? It looks like it's heading towards 0. At 1.01, I have 0.0201, 0.0404. Where is that headed toward? That is also headed towards 0. So what this is saying, again, if we were to graph this, you know what this looks like. You have a shifted parabola down right here. But they're asking at the point 1, right here, where am I heading from the left and from the right? What is the limit? Well, the limit is 0. So your answer will be 0. And we're going to do this for every single problem today. We're going to make a table. You can even make a graph if you want to, just so you can visually see what it looks like. Let's do number 2. So whenever you have a fraction, I've said it yesterday, I'll say it again, please, please, please put parentheses around the top and the bottom, no matter what. Put parentheses around the top and the bottom, okay? This is our start. So I make my table, I'm going to have 3 right here. I'm going to have 2 before it and 2 below it. So y equals parenthesis x squared minus 9, close the parenthesis, divided by x minus 3. Set your table to 3. Keep it at 0.01. Second graph. Go up 2. Notice there's an error in the graph. I still want you to copy it down. So we would have 2.99, 2.98, 3.01, 3.02. And let's see what we get. 5.98, 5.99. And 6.01, 6.02. What does this mean? This looks like it's headed toward the value of 6. So does this one. So does this have a limit? Yes, it does, even though there's an error here. Because if you were to hit graph right now and look to see what this looks like, it looks like a straight line, except at the point 3, there's a hole in the graph, which your calculator doesn't show you. At the point 3, there's a hole in the graph. But as we approach it from either side, I'm going towards 6. And remember, we did this yesterday on graphs. I can have a hole in the graph and still have a limit. This is 6, as long as these two are the same. All right, let's do one, assign x. Okay, real quick, you need to be in radian mode when you're doing trig problems. If you are not in radian mode, hit mode and then go down to radian and hit enter. But you definitely need to be in radian mode when we do trig problems. So Once again, I'm going to hit parenthesis because whenever I have a fraction, just put parenthesis around the top and the bottom. So you have sine x. Now this is complicated because they put an extra parenthesis in there. So you have to go close, close, divided by parenthesis x. Set your table at 0. Go to your table and go up 1. Again, look at that. There's an error there. There's a hole in the graph that you wouldn't have known. Oh, make a little note right here. Radian. Okay, I want to make sure you're all on the same path. So 0, negative 0.01, negative 0.02, 0.01, 0.02. Looks like I'm at 0.9993, 0.9998. Error. 0.9998, 0.9993. Again, if I'm going from the bottom and from the top, looks like I'm approaching 1. And that's because if I hit the graph, yeah, it's not drawing it so nice because of the way this is a 10 by 10. But if I actually made it a little bit better zoom fit, there's a hole in the graph right there. Okay, but I'm still approaching from either side. I'm approaching 1. So this has a limit of 1. By the way, this is a very important trig limit that we are going to find out. So highlight this or box this. The limit as x approaches 0 of sine x over x is equivalent to 1. It's equal to 1. Know that limit. We're going to do something with it in the next couple of lessons. All right, now for 4, 5, and 6, these are actually all the same. These are just doing one-sided limits. Remember, this is the left. This one's on the right. And this one is the limit from the left and the right. So let's do this one. Put it in my calculator. Absolute value is math num abs. And you don't have to put a parenthesis around that one, but I will put it around the bottom. Whoops, divided by parenthesis x. Set your table to 0 and go up 2. Well, I just went up 3 spots. So here's how you do a table for a left and a right. So for the table on this side, the left, I want what's coming before 0, to the left of 0. So I will write a table as such. Negative 0.03, negative 0.02, negative 0.010. There's an error at 0. Makes sense. You can't have 0 on the bottom. But all the values are negative 2. So that means it's approaching negative 2, which means it does have a limit. The limit is negative 2. For this one, I want to approach 0 from the right. So that would be from the bottom up. So I would say, okay, 0.03, 0.02, 0.010. And it looks like I'm at 2. Well, then that's my limit on the right. But does this have a limit without a little symbol next to it? No. Remember, these two have to be the same in order for this to have a limit. So this one would be DNE. Does not exist. And you can see that in the picture here. You actually graph it. Notice at 0, when you approach it from either side, you have, if you're approaching along this left, you have a limit. Here you have a different limit. So those are not the same. That's why it does not exist. All right, so we have just covered 6 examples. Let's do our last 3. And again, I forgot to tell you, I pre-wrote all these. So if you want to pause the video at any time, you can pause the video, copy these, and you should be on track and following along. Just want to talk about some infinite limits real quick. So if you notice, I'm doing the limit as x goes to 4 of 1 over x minus 4 squared, and then the limit as x goes to 4 of 1 over x minus 4 cubed. Just to notice something that happens. So when I put this in my calculator, 1 divided by x minus 4 squared. And I want to start at 4 and go up by 0.01. And go up 2. All right. So when I start to write this, I have 3.98, 3.994, 4.01, 4.02. So it looks like I have 2,500, 10,000, an error, which makes sense, can't have 4 in the denominator, 10,000, 2,500. So a lot of students would probably look at this table and think, oh, it's going toward 10,000. Well, this is a point where I would actually do another table. This is your change of table is at 0.01. So let's change our table to actually be even more precise, 0.001. If I do that, set it at 4, do 0.001. Now look at your table. Now your table at 3.998 is going to 250,000 at 3.998, 250,000. At the decimal 3.999, we are at, looks like 1 million. And then from the left side, same thing, 4.001 is 1 million. And 4.002 is 250,000. Now, again, students get all confused. They're like, well, am I going to 1 million? Am I going to 10,000? What am I going to? Well, let's take a look at the graph. The graph, we've just learned yesterday how to do that. So let's see what's happening here. Oh, look at this. As you approach 4 from the left, my pen is going toward infinity. From the right, my pen is going toward infinity. If you look at these tables, they are getting increasingly large. They are both headed toward infinity, and that is a limit. You can have a limit of infinity as long as they're both approaching the same infinity, either positive infinity or negative infinity. So just to graph this for you, there's an asymptote here, and they're both approaching infinity at x equal to 4. Well, what happens if I made it same thing, 1 over x minus 4 to the third power? Just let's see what happens there. 3. Graph. Just so you can see. This one's going down when you're reaching 4. This one's going up. Oh, so this one is headed toward negative infinity. This one is headed toward positive infinity. Those are not the same, okay? And you can check your table real quick. We can go to 4 again and go up 2. And let's just write this table out, because I always think it's good to write tables no matter what. 3.998 goes to negative 1.3 e to the 8. What does 0.3 e to the 8? So that would be negative 1 and then 8 places of the decimal. 1, 2, 3, 4, 5, 6, 7, 8. So negative 130 million. This one is negative 1 with 9 decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. There we go. That's even larger. So this is going toward negative infinity. Whereas at 4.001, we are now headed toward 1 with 9 zeros. And 4.002 is 1.25 e to the 8. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm going toward infinity here, but negative infinity here. And that's what the graph was saying. Sorry for the glare. But when x was 4, your graph was going like that toward negative infinity, but up here is going toward positive infinity. Well, that means, again, these two have to be the same, so this does not exist. All right? So watch out for that. Those are asymptotes. This is what happens when you have asymptotes, just so you know. definitely issues with asymptotes. All right, one more. How do I do this? How do I punch in negative infinity? Is there a symbol? Is there something on the graphing calculator that I can do that? Not really, but we can finesse it. So just to show you, let's put this into our calculator real quick. And when there's a fraction within a fraction, I probably make its own separate set of parentheses. So let's see. I would do -3 divided by x squared. And then you want to do that plus 2. Okay, so where do I start my table? Well, you start your table at, again, negative infinity means a large negative number. So start it at like, I don't know, -100. And then change it to -1,000. And then change it to negative, a million. And look to see where you're headed. So -100. And you can keep it at 0.001, but I'm going to go back to 0.01. Let's see, it looks like I'm at 1.9997. And then go back to table set, and now make it go to -1,000. 2. -1,000,000. Again, you just want to get increasingly larger. 1, 2, 3, 4, 5, 6. Still headed toward 2. Okay, so as I get larger, as I get largely negative, my limit is headed to 2. All right, so hopefully that was good information for you. You're just doing all of the same thing on your homework tonight, which is a worksheet, by the way, that looks like this. Okay, you are doing selected problems on this worksheet. Make sure you write down the selected problems that I have. And I want to see a chart for every single one. And that's it. Hope you do well. See you tomorrow or see you next week. Bye.